Okay, so welcome everybody to Computer Science 3200 and Computer Science 6980. So this is what they call a piggybacked course. So undergrad students and grad students will be in the same lectures. So all the things that I say will be the same for both classes, but then the main difference between both the classes is that the graduate students will have to do a bit of additional reading, and on every assignment there's like a bonus thing that the grad students have to do. And so that's to distinguish it, so you know the undergrad students aren't taking the exact same course, even though the lecture material is going to be the same. So what I'm going to do is I'm going to start out by just, I know that a bunch of you have already visited the Brightspace. So this is called Brightspace. It used to be called Desire to Learn, or D2L. So if I say Brightspace or D2L, those terms are just interchangeable. So if I say D2L, I mean this. That's why the URL actually has D2L in it. So here I'm going to go over the intro post that I made. I'm just going to read it out, and if there's any mistakes there, I can fix them, and if not, then we can get on with the rest of the stuff. But this is just an introductory lecture. I'm going to spend probably the majority of the class just talking about how the class will run, and then at the end I'll have a few lecture slides, maybe like 20 minutes, possibly 30 minutes of actual content about AI and stuff. So my name is Dave Churchill. I've been a professor here since 2016. I also took my undergrad and master's at MUN as well, so I'm been at this university for a long time, and this is one of my favorite courses to teach, so I hope you all enjoy taking it. And just before I get started, no, this is not a class on LLMs or machine learning. There is another class for that. So this is more of a class on classical AI algorithms, not necessarily the bleeding edge stuff that you'll be doing with deep neural networks and also all that kind of stuff. So here we have the Brightspace shell. I'm going to just zoom in to get rid of this other sidebar here, and I'll just start reading. So, hello everyone, welcome to Comp 3200. Thank you for registering for the course. Our course this term will be in-person lecturing with in-person exams. This class will be taught simultaneously with Comp 6980, the graduate version of this course. So I'm reading from the Comp 3200 version of this post. It is identical to the 6980 version. It'll be very unlikely that I'll make any posts to one that I don't make the exact same to the other. However, if there's some clarification to like the grad version of the assignment, then I'll post that only to the 6980 Brightspace instead of confusing the undergrads with that. So this means both grads and undergrads will be present for the same lectures. The main difference will be the two versions will be the increased difficulty of the assignments and exams for 6980. So here's some information. So the class times Tuesday and Thursday from 2 p.m. to 3:15. You're all aware of that because you made it here, as well as the classroom. And this is the first class. The first link here is the Google Spreadsheet. I don't know if you've had a look at that, but by default, I'm a pretty disorganized person in my life. And so when it comes to my professional life, I like to be as organized as possible. So here is a spreadsheet which will detail absolutely everything about the course. So if you ever know what a lecture is going to be about, when an assignment is going to be given out, when a lecture is over, typically that evening, I will post the video to YouTube. And so I do record my lectures. However, there is the possibility that a recording fails. Okay, so if you don't come to class, just be aware that you may miss an entire lecture if the recording just doesn't work for some reason. Last year, I managed to get away with only one recording not working, but in the past, for whatever reason, that may be more. So I understand that this is by far the most people who will ever be at any lecture. We'll probably be down to like 15 or 20 people by the end of the year, if I'm lucky. I get that. That's just the nature of releasing lecture videos. But I will also link the slides here as well. So, you know, at some point, typically within 24 hours, but up to 48 hours is when I put those things on the website. So coming to class, you also get the chance to like ask questions and interact and get the material before someone who didn't come to class. Over here, we also see all the different assignments and their due dates, etc. Those should be pretty set in stone. Except, you know, if we end up having like, I don't know, 5 snow days in a row or something like that, that could potentially change things. We will not be missing any lectures. If we do miss a lecture, I've taught this course for many years and I have a bunch of recordings. So for example, if there's a snow day for lecture 5 and the university is closed, I will not be shifting the entire schedule. I'll just be giving you that video instead. So that's a much easier way rather than constantly shifting around the schedule. Yeah, so that's the class schedule. You can see here there's like midterm breaks and stuff. I don't know when the final exam is yet, but I will put that in afterwards. The midterm exam will be the lecture right before midterm break. So you won't have to be stressing about the midterm for the whole break. Okay, so some general course information. This course will make use of D2L, that's this, my website, and Discord. So just to go over my website, it may be a useful resource to you. So the teaching part of my website, I just have my, my pets up here on the top. So these are the courses that I'm currently teaching, these 3 courses. And down here are the past courses that I've taught. And so all of the lecture videos and slides for every course I've ever done are just publicly available. So if you're super keen and you want to look over the notes for a lecture in advance, you can download the lecture notes from the previous year, or you can watch a lecture video from a previous year. Just keep in mind that it is entirely possible that a lecture or the slides will change from a previous year, because I do update them a little bit every year, right? There's some algorithms, of course, that never change, the math never changes, but I do update things. But if you really did want to, for example, a few years ago, someone said, hey, can we have the lecture slides in advance so I can make notes on the lecture slides? And so if you want to, you could just come over here and download. This is a link to a zip file with all the PDFs from the previous term, and you can have those to make notes on them if you want. So they're just available there. And this has a link to the spreadsheet, and as I go, then this is where the links to those videos will be, but also there's a link here to the playlist that will contain all the YouTube videos. And of course that link right now is blank because I haven't made any videos yet. Come on in. And so once I put a video on YouTube, there will be a YouTube playlist created for that. Okay, so that's pretty much all I have to say about that website. It's more of just a useful resource for me and for you to access past materials if you want to. And also over here, these links go directly to the D2L shell for the course. So I have a ton of courses in my D2L, and so that's why I have those links there, so I can go straight to those websites. All course material will be conveniently linked on a Google spreadsheet, which I've already shown. Yeah, the link to the spreadsheet and the course syllabus, etc., will be found on my teaching website here. And I'm not going to go over the syllabus itself. I'm not going to open up that PDF because I've already taken that PDF and put parts of it into this lecture. And so I don't need to actually open that PDF, but the syllabus is there if you do want to see it. All important course announcements will be made via D2L, and you can enable email notifications for D2L if you haven't already, so that when I do post, you'll get a notification that I have posted. Sometimes what I will also do is do like an @everyone notification on the Discord for important things as well, but the Discord server is completely optional, and I see like 30 people have joined already, so that's great. But yeah, it is completely optional because it's a third-party piece of software that's not officially supported by the university. I will make announcements there as well, but they will just be duplicates of whatever I've said on D2L. So you won't miss anything if you don't have Discord, but there is oftentimes discussion going on and questions being answered in Discord. So if you're already on Discord, it's pretty helpful sometimes to be there because, you know, you can send me a DM like about a question or whatever about grades. It's typically the fastest way to get in contact with me. Assignments work a little bit differently in this course than in other courses. So instead of just having like an assignment that everyone downloads, I make individualized assignments. So I take the assignment and then I have some software that I wrote that personalizes that assignment to you. So the assignment is still the same, but what it does is, because in the past I've had problems with people like putting the assignments on GitHub and, you know, like assignment sharing websites and stuff. It doesn't happen as much now because of ChatGPT. It just solves all your problems, right? So not many people are cheating via actually sharing the assignments anymore. but I will be emailing you a link to your @mun.ca address with a URL where you will download your assignments. And so if you're looking for where the assignments are, you will get an email that has 5 different assignment links. That's assignment 1 through 5. All of those links will be inactive at first, and then as the assignments are released, you can click that link to download your assignment. So make sure you keep a copy of that email so that you know where the assignments will be for future downloads. All assignments will be submitted via D2L as a single JavaScript file for each assignment. So I'll talk a bit more about that in a bit, but all the assignments will be done in HTML and JavaScript because this is a algorithms course. It doesn't really matter which language we write stuff in. This is not a course about low-level memory optimizations or memory pooling or anything like that. This is an algorithms course. And so what JavaScript lets me do is I can give you a really nice user interface for the assignment, and then you just write the back-end algorithm, which is going to power that user interface. And so it's a really nice system. It also makes it so that you don't have to use any specific IDE. It works on any operating system. You could probably do your assignments on your phone if you figured out how to do that. This is what I just said. So your assignments, I'm going to make an assignment that has like your student number, a little copyright information, your name, your email stuff, so that if the assignments are released online, then I can trace them back to whoever put them online. Anyone's assignment found publicly online for any reason, that'll just be essentially the same as cheating or plagiarism. So don't share your assignments anywhere. You are completely free to use GitHub to collaborate because all of the assignments in this class will be, you can do them in groups of up to 2 people. So you can do them solo if you want. However, I strongly recommend doing them with 2 people because they were designed to be enough work for 2 people. Okay? Many people have done them all solo. It's fine. But like if you're doing 5 classes and you don't want to have that extra work, it's nice to have someone else to bounce ideas off and do half of the typing, right? So you can use GitHub, just make sure that the repo is private. And usually a couple of weeks into the term, I'll have a search on GitHub for specific keywords that show up in my assignment. And you're not just gonna like fail the course or be kicked out of school if you forget to click private. I'll just remind you, hey, please make this repo private so that the assignments aren't being shared. All assignments will be done using basic JavaScript and HTML. You will need to be familiar with JavaScript classes, functions, variables, loops, and arrays. So it's extremely basic programming, right? If you have never used JavaScript before, you will be absolutely fine. The first assignment is going to be an easy assignment conceptually so that you can get used to the sort of architecture of my assignments in the class. And the classes, functions, variable, loops, and arrays, it's basically, if you've used Java or Python or whatever, it's pretty much the same. It's just a little bit of syntactical difference. I'll get into that a lot more once the first assignment is released. I'll give you all the details about that. Here's an important thing. Each student will be given a one-time, no questions asked, 48-hour extension for any assignment submission. And so when I say each student, if you're working in groups, this will be applied to both people in the group, right? So you don't each get a separate one. You do not need to contact me in advance to use this extension. The TA will see a late submission and ask if you're using your free extension. So you just get a one-time, no questions asked, it's 48 hours late, that's fine. But if it's not that, then any late assignment will lose 5% per hour they are late, rounded up. So for example, if you're 2 minutes late, that's rounded up to 1 hour and you'll lose 5%. If it's 2.5 hours late, that's rounded up to 3 hours, so you'll lose 15%. And the reason I do this is because, you know, in some classes they'll say late submissions are not accepted, and then you get a few people who are like, oh, my internet went out and I'm only 3 minutes late, could you please accept it? And so in order for me to just rid myself of all that headache, that's the rule, and there are no exceptions to that rule. So if you need that extra hour, you can take the extra hour, but you'll just lose 5%, right? So that's pretty easy. Academic misconduct. I'm going to talk about this a lot more in the lecture slides, but no use of ChatGPT, Copilot, or any other automatic code generation is allowed in this course for the completion of any graded material. That is very important, and statistically, 15% of you will ignore that and try and use it anyway. I say that every term, and I'm right about it every term. I just finished up my game programming class, and it was 13% of students got hit pretty hard for using AI. Whatever material you hand in for this course must have been solved and typed by you, the human, right? Now, the exception to this is I know that sometimes there's like some autocomplete, like if you type like array.sort, it might put in the brackets for you or whatever, but take out the Copilot putting in paragraphs of code for you. I cannot stress to you how obvious it is when people use AI to code for them in this class. Just imagine that you're speaking to someone in like, okay, so I'll just use English because that's the language that I know best. You're speaking to someone in English and they have a very strong accent, right? They're from somewhere else. Hugely strong accent, but then one paragraph that they say is like Shakespearean English, right? You would all be able to see that. Trust me, that's what it's like when I look at some of the assignments. It is like, oh, this person barely knew anything in this function, and now they're writing like advanced senior dev JavaScript in this function. Trust me, it is not worth it to try and get away with using AI in this course. If your plan is to just use AI and do all the assignments, just drop the course, please. It will not work out well for you. Now, I use a very, I'm not just, oh, I think they used AI and then I give you a 0 or whatever. I have to be very, very certain. And I've never been wrong about it, right? I'll let people go free who I only think did and only like actually pursue the people who I know did. But just, it's really, really easy to spot it, especially for undergrad students, third year, your first time writing this type of code. Trust me, it's just way easier to actually learn and write it. And because in previous years, I've had issues with this where it's like some people, oh, I did this, I was, you know, this happened in my life or whatever. Just a very simple rule this year. If I know that you used AI to do your assignments, we're just automatically submitting that to the department as an academic misconduct case. And for the grad students, that will have a very, very negative effect on your program. So please, especially if you are a grad student, do not use AI to solve these assignments for you. It is not going to work out well. Oh, in addition to that, I have office hours after every class. So from 3:30 to 5 is when I have my office hours, which is after each class. Who in class has a class right after this one? Anyone? A few people? Okay, is that undergrad class? Yeah? Okay. So maybe I'll change that to allow for, which class is that? Is right after this one? Machine learning. Okay, so maybe I'll change it so that I can, maybe instead of 3:30 to 4 or 3:30 to 5, maybe I'll go like 4 to 6 or something like that. So, but I'll announce that. But if you're having trouble with your assignment, come see me at the office hour. I promise you that you will not leave my office without at least part of your assignment working correctly. That is my job. I enjoy helping people. And so if it's ever a decision between going to the office hour or asking me a question on Discord and using ChatGPT or Claude or whatever, one of those is a lot better than the other, right? I really want you to learn this material. So I have a Discord. It's not required. I already kind of went over this. The Discord link is up here at the very top. A bunch of people, probably half the class has already joined. That's awesome. I'm not going to mouse over that because I don't want the URL to be on the video. So that's why I don't just type it in there. So that's why. Just be sure to change your nickname because I've had some incredibly degenerate usernames join the channel. So if you're, you know, asking me a question, please at least put your first name in there so I know that I'm talking to a human being. Lecture delivery. So I will be giving all the lectures in person here unless there's a snow day. All lectures will hopefully be recorded by MUN's in-class lecture system. But what I do is I actually download the lecture capture videos and then edit them because I also record a higher quality version on my laptop. So You won't have to use that ridiculous double lecture capture player that is absolutely horrendous. You'll see when I post the first video, if nothing has gone wrong, what the lectures will look like. All the videos will be posted to YouTube. Oh, it says D2L here. I no longer post the videos to D2L because there was a new file size limit that was introduced of like a gigabyte or something, and it messed with it. So the videos are just on YouTube. If you can't view YouTube for some crazy reason, let me know and I'll try and put them somewhere else for you to view. All lecture slides and videos will be available on D2L via the course spreadsheet. So again, you can just click here and see. Let me just show you an example. So if I go over here to a previous class, like last year's, by the end of the term, all of these will be filled out and you can just click YouTube or PDF and you'll go straight to those videos. We will not miss any scheduled lectures in the course. If there's a school closure or I cannot attend a live lecture, I will post a recorded video. The only exception to that would be a missed exam. Like if our exam day, the university is closed, then I'll have to reschedule the exam. But it shouldn't affect the overall schedule. That exam slot would just be flipped with a video that I release or something like that. Just because the lectures are recorded, you're still encouraged to attend class. There will be discussion. Any discussion before or after class will not be included in the lecture videos, right? So if someone asks if there's a Q&A and I say a bunch of stuff about what will be on the exam, that may not be on the lecture video. I typically cut it off when the lecture ends. So just coming to class is good. And I can say, statistically speaking, the people who do best in the class are always the people who show up to class. Now, I don't know if that is just a correlation or if that's causation, but statistically, there is a correlation between class attendance and how well you do in the class. Exams. This class will have an in-person midterm and final exam, and I'll give all the details of that in a future lecture. And because I'm reading from the 3200 one here, something that I'll announce later is that for 6980, the grad version of the class, there will be an optional project that you can do for up to 10% extra grades at the end of the class, at the end of the course, but I'll give details of that. That won't be relevant for months and months, so we'll talk about that when I get to it. Okay, so now let's go to the slides where I have a bunch more details. So, there's something really weird in the PowerPoint got updated, and now what I have to do before every lecture is actually switch my view to presenter view, and now I don't have it on my slide. Okay, hang on a second. Operating system updates always mess everything up. Oh, this is why everyone's using AI to write their software now, and it's absolutely terrible. All right, so I'm going to have to go without presenter view, which is really annoying. I'm going to have to figure that out later. Okay, so typically I can see what's coming up next on the slides, but I can't right now. All right, so lecture number one. I'm going to go into a bunch more detail about some of the class stuff first before I talk about this stuff. So Intro to AI. This class is about classical AI algorithms. And if you ask a lot of people these days what AI is, they think that AI is just LLMs, ChatGPT, and machine learning. It is absolutely not. AI has been around since literally the 1950s, and there is lots of stuff that is not machine learning. We will go into, at the very end, a little bit of reinforcement learning, which is a sub-area of machine learning, and just give a little bit of intro to neural networks. But 80%, 90% of this course has nothing to do with machine learning. This is about algorithms that have been used in AI for many, many years. And you may think, well, when would I ever use those? We'll see how these have a lot of great uses, especially in situations where you don't have an RTX 5090 to run your models, right? There's lots of AI that can be done on really, really meager hardware, which is great. So we'll be talking a lot about search algorithms, optimizations for those algorithms, Actually, I don't have constraint satisfaction in this version of it, so I got to take that out. Evolutionary algorithms, reinforcement learning, and neural networks. So the course goal is to learn about artificial intelligence and implementing those algorithms from scratch. So we are not just using Python, import assignment 1, import TensorFlow, import whatever. We are going to be coding these algorithms absolutely from scratch, and hopefully that will let you learn how to identify problems, choose representations for your code to be able to solve those problems, and then come up with solutions for those problems. So we'll describe the very nature of the problems, and based on the nature of the problems and the property of the environments and the agents in those problems, we'll be able to determine, oh, I could use this algorithm, and I can't use that algorithm for whatever reason. So this is all about learning. We want to understand which algorithms to use in specific scenarios, the benefits of those, and the drawbacks, right? So if you're at some company later on and they're like, oh, we need something to solve this, let's use ChatGPT. And you can say, actually, we could use like an algorithm that runs instantaneously on a Raspberry Pi instead of spending $100,000 a year on this thing that we don't need. I've said this stuff already, so I don't need to say that again. There is no textbook that is required, but I do list 2 textbooks on the class syllabus that are optional, but you can use them if you want to help you study for the exams. The first one is the AI textbook by Russell and Norvig, and the first half of this course is structured based on that book. The second one is the reinforcement learning book by Sutton and Bartow. That one is actually available free online, so you can read along with that one if you want. As such, the slides are designed to be study material, so there's more text than usual. So I like giving presentations, and I feel that good presentations oftentimes have very little text on the slides. So it's sometimes annoying that there is so much text on the slides. It will feel like I'm just reading from some of these slides. Most of the time, I do give extra information. Like right now, the things that I'm saying are not here, right? But what I've done is I have designed the slides to be what you study, right? So you're studying from the exam, you look at the slides. You can absolutely look at the textbook if you want to, but that's why there's a bunch of text on these slides, so you can use it as a reference to study. That is how I've designed it. So you should be able to do all of the assignments and study for the exams from these slides. Something that I run into with maybe 10% of students traditionally in this class is that the assignment will be on a particular algorithm, for example. Let's say the A-star search algorithm. And what some people will do is go to like Wikipedia and take that version of the A-star algorithm and implement it. Or some other website, or ChatGPT, etc. The algorithms in this class are going to be taught in a very specific way so that you'll kind of get a story, right? I think all good teaching has to tell a story. Like there's a beginning, a middle, and an end. As humans, we have evolved to be storytellers, not just fact memorizers. So I'm going to start at breadth first search and work all the way up to some more advanced search algorithms. And the reason for that is because at the end of that, you'll understand how all of these algorithms are really related. They're almost the same algorithm with just 1 or 2 line differences. And if all you do is go to Wikipedia and grab the A-star algorithm and implement it, you're really missing that. And I can tell when that has happened. So trust me, the easiest thing to do is to take the version of the algorithm that's in the slides and implement that. Because I turned on Do Not Disturb on my phone. Apparently that doesn't work. Just give me a sec. All right. So, apologies. So the versions of the algorithms in the slides are designed to be the most understandable and simplest versions of those. If you do find that some other version of the algorithm is easier for you to understand, that's fine. But just keep in mind that it's probably not going to be as easy to implement within the framework that I'm giving you for this class. And we'll talk about that a bit more when we get to assignment 1. And the lectures are going to be a mix of me reading from slides and demos and visuals and math and stuff like that. And just keep in mind that some of my lecture videos do have, or my lecture slides, right now I'm giving a PowerPoint presentation. Some of them have animations in them. When you get the slides, they will be static PDFs. So if there's an animation in the PowerPoint, that will not be present because PDFs don't have those sorts of animations. So just be aware of that. If you do want to see the animation again, you can always pull up the video if it exists and watch it. There'll be a total of 5 assignments, and they will be worth 35% of the course mark. Unfortunately for you, I believe personally that the assignments are the most important part of this class. I believe that implementation is understanding. You could answer exam questions all day, but unless you've actually implemented it, you don't understand it. And it's unfortunate now the assignments are worth about 1/3 of this class, but we just have AI coding to thank for that. There is no way for me to evaluate you truthfully on any take-home stuff. It sucks. This used to be 50% of the class, but it's just gotten real bad out there. Trust me. I am turning into Detective Churchill instead of Professor Churchill because of all this. So assignments are worth about 1/3 of the class, and the exams are going to be worth the other 2/3 of the class. Groups of up to 2 do not contact other groups. And each assignment will be to apply a learned algorithm to a simple game-like environment. And I'll give examples of that in the future. What I also like to do is every assignment is also going to have a little sort of bonus competition. So like whose code ran the fastest or something like that. And if you get like the top in the class, I'll give you a little certificate that you could show off if you wanted to. Because I find that if you are like me and you really like those details, you'll oftentimes learn more doing that bonus stuff that's not worth any marks, it's just worth sort of street cred in class, than you will actually doing the assignment itself. So I like to throw those in there as well. And the midterm and the final will be 65% of the course mark. And so just unfortunately, it's hard for me to trust assignments, and written exams are the only real way to test the knowledge. And there is a lot of really nice testable knowledge in this class. So the algorithms, they do translate well to paper exams. It's not all about the programming. And my exams, I think you can ask anyone who's taken my classes, the exams are never overly difficult, but they are comprehensive. So they'll typically test almost everything, but there's no gotcha questions or tricky examples or anything like that. People come out of the exam and they'll say, well, what I got wrong was the stuff I didn't study, right? So I don't try and give hard exams. I don't understand these profs who get up and say, oh, only 6 of you will get an A. Like, if every single person in this class gets 100%, that would make me the happiest person in the world. I don't grade on curves. What you get is what you get. Okay, so if everybody does great, I feel like I've done my job well. I'm not here to trick you. My job is that in order for me to say that you've passed the class, you have to have demonstrated to me that you truly know the knowledge. That's it. It's almost like a business transaction. You give me the work, I give you the grades, right? So this slide is incorrect. Apologies, I forgot to edit this one. This is what's in the class syllabus. This is 35%, and this is 40% for the final exam. Okay, this is about the 48-hour extension. I've already mentioned that. Every assignment is going to be due at 11:59 p.m. on the day that it is due. Unlimited submissions are allowed, so you could submit 50 times, right? If you think you're done and you submit it and then you find a bug and you resubmit it, only the last thing that you submit is kept. So we don't have like all 30 versions. You're not going to annoy us. I set it up so that only the last version is kept. And you lose 5% per hour that the assignment is late. So I've already discussed that. If there's a special circumstance, like you're sick or whatever, I completely understand that. If you come to me, hey, I've been sick, I've been missing class for this reason or whatever, then that will not count toward your 48-hour extension. Just keep in mind that for whatever happens in the class, if you come to me looking for an extension on the day that it's due, I'm going to be much less sympathetic, because that tells me that there was a problem and you just put it off until the last minute. So if your partner drops the class or you get sick or whatever, just tell me in advance so I know that it's real and you're not just like trying to get a little bit of free time at the end. So who here has done any JavaScript programming before? Okay, about half the class. That's fine. If you've done any programming at all, you'll be fine with this. Ironically, I have had graduate students in the class before who somehow have never done any programming. If that is the case, we need to rectify that immediately. So please come to me if you are a graduate student who somehow got into our program and is very, very, very unexperienced with programming. There's no shame in that. Just come to me and we'll rectify it. Don't wait until the assignment is due, please. What's going to happen is I'll give you a working user interface and you write the back-end algorithm. That's it. I'll show you that when we get to assignment 1. Very, very basic JavaScript stuff. And so you will not use a specific IDE. I don't care, whatever you want. You can use the terminal, you can use Vim, Notepad. I just suggest Visual Studio Code because it's nice and it works on any operating system. Who's used VS Code before? Yeah, so a bunch of people. It's absolutely fine. And I'll give all the details of that when we come to assignment 1 on the lecture. I will walk through from opening the zip file to coding up the assignment. So assignment 1 is sort of the tutorial assignment, and only if you have absolutely no programming knowledge at all do you need to worry about the assignments in this class. Cheating and plagiarism, I've already said that. The last line here, I do like to reiterate, there are valid reasons to hand something in late. There are valid reasons to miss class, but there is no valid reason to cheat, okay? So, oh, that's okay. I'm not that boring that you need a podcast. Okay, so if you do use AI to generate your assignments, that is a conscious decision. It is not a mistake. I get people, when I catch them, I pull them into to the office hours, and I'm like, come on, this is really obvious. And they're like, oh, sorry, it's a mistake. It'll never happen again. It's not a mistake. The only mistake is getting caught, right? Like, you feel bad because you got caught, but you absolutely tried to do it on purpose, right? I've had thousands of people in my classes. I know that it's definitely a conscious choice to cheat. You didn't just slip and fell on ChatGPT with the assignment in it, right? Okay. I don't need to reread all of that. That is just saying that you have to do your own work, okay? I just put it in writing on the syllabus so that if some investigation with the university does happen, I've covered my ass here. I've told you what to do. So I said this already, because people like to share their stuff online sometimes, your assignments will be personalized and traceable back to you. I periodically search for GitHub. Some people, now I've designed these assignments such that they're visually appealing, both for debugging purposes, but as well as you can use them in your resume or your portfolio, and many students have done that. The only thing I ask is that you don't release the source code. So if you have an online portfolio or a website, you can put up videos or screenshots or descriptions of anything you've done in this class, but just don't release the source code. Please, that's all I'm saying, just so people don't go look at that. And also, because this happened once where someone took an assignment from this class and submitted it as a project for another class, the university does not allow that. So you cannot use any submitted material from one class as a submission for another class without explicit permission from both the professors, okay? Even if you go to another professor and ask, can I submit Dave's assignment for this class? Even if they say yes, it's a no, because I don't want this class's stuff being submitted to other classes. All right, here's where I rant about AI for a little bit. So anyone get this Simpsons reference? Anyone? No? Okay, so a couple people nodded. Anyway, this is Abe Simpson, and this is the cloud, right? Anyway, I'm clever. All right, so AI-generated code. I know that all of you just think I'm some old man who doesn't like AI because it lets you cheat. That is not true. That's partially true, but it's not completely true. Here's the catch-22, is that in 2026, it is impossible to give an assignment that a student can solve that an AI can't solve. That's my problem as an educator that I have to somehow work around, Okay, that is a big problem. This presents a very difficult situation for education as these tools improve. I do believe that we are currently at this like point of diminishing returns, and the promise of AI being literally being able to do everything, that is not true at all. They'll still hallucinate, they'll still make mistakes. I don't believe it'll ever be perfect. The temptation to press 3 buttons and have your assignment completed for you is a very strong one, but a very dangerous one. Let's take cheating out of the equation completely. When these LLMs and these autocoders started coming out, I started using them a lot. I have been programming since the mid-90s. That tells you my age. I found myself in about 3 months of using LLMs, I had lost years of programming ability. It's really weird. It's like if you've gone to the gym every day for 10 years and then you stop going to the gym. You don't stay at the same level of strength. It goes down, and it goes down very quickly. It's surprising how this happened to me. I had to cut back on my use of them. I still use them, mostly as API lookups and stuff, but I do not get them to do my programming for me anymore. All right. It will make you worse at programming. I like to call it like an academic heroin, like an academic drug. It will feel amazing the first few times you use it. But then if you're ever in a situation where you don't have it, you literally have withdrawal symptoms because you can't feel that way without it anymore. It is a very good analogy if you actually understand it. Okay. The point of university sometimes is misunderstood. I get your side of things. I was a university student for a very, very long time. The point of this class is not for me to just collect working assignments. I have so many working assignments, and if I didn't have to look at them, I wouldn't, right? I don't want working assignments. What I want is to produce students, or to help you learn how to solve these assignments on your own. It's this wonderful concept of actually learning the thing and becoming better at the thing that you hopefully want to do for the rest of your life. If you're a grad student in computer science or a third-year student in computer science, you're probably thinking about this for your career. And using this time in order to become as good as you can at that is probably the right way to go. And this is a very important distinction. I hope you understand that distinction, right? It's not just that I get a working assignment, is that you have learned and done it on your own. And that makes me the happiest person in the world when people actually learn and implement things on their own. So there's 2 solutions to this problem of AI in education. One is to catch the students who hand in AI-generated code and then punish them academically. I hope that I never have to do that again in my life. It takes up so much of my time, and it feels bad for me to do it. I don't take pleasure in that. I don't want that to ever happen again. So therefore, I can hopefully convince you that it is extremely beneficial to not use AI tools to automatically solve your problems. Okay, why? So there's 2 ways to effectively use AI tools. One is to prompt the tools with the assignment and get it to solve it for you. You could, if I, for example, wrote up a text file describing the assignment, you could probably drag that into whatever LLM of your choice, and then it would produce working code for you. Now, it would probably be pretty easy for me to spot, but you would get a working assignment out of it. Anything that I could do that LLM, or any assignment I could give you that an LLM couldn't solve would be way, way too difficult for a classroom setting. The second way would be to solve the problems yourself and use the AI as a tool to help with small coding issues, such as programming language syntax, API calls, etc. So for example, if you forget how to sort an array in JavaScript, that is a fine thing to use Google or AI for, right? So it's kind of like, if I would use Google for this, it's okay to use AI as maybe a better Google. Or if it's part of the code that you don't understand, and you copy and paste, say, please explain what this piece of code does. That is a great thing to use AI for, to get it to explain things to you, but not to get it to solve and implement, at least in this class. So if you use AI tools as an API reference to help you learn, it's incredibly, incredibly powerful. If you use AI tools to implement the code for you and just copy and paste it, that is cheating for the purposes of this class. And it is also extremely harmful for you learning the class material because you'll get behind, and then when it comes to the exams, trust me, the difference is clear. When I get someone handing in 90, 95s, 100s in all the assignments and then gets like a 20 on the exam, well, now I go back and look at the assignments and start to notice, oh, okay, they maybe didn't do this on their own, right? So just keep that in mind. Never under any circumstances submit or push a single line of code from AI that you don't understand. This also is industry relevant. If you don't understand the code that you have pushed to release, what have you done? Right? How can you verify that it works if you don't understand that line of code? It's extremely dangerous. But you all say, I will be using AI all the time at my job. My buddy who works at company XYZ uses AI all the time at his job or her job. Also, not only do they use it, but their management is now mandating the use of it, right? You have to use AI in order to be an effective programmer. I could talk about this for hours, but trust me when I say that the AI companies, the 5 companies currently controlling most of the world's AI, have convinced middle management everywhere around the world and sold them all the subscriptions. And now all this management and all this money is spent on something that they have to use. And if they don't use it, they feel bad, they can't justify their salaries, etc. It is not just a plug-and-play solution to all of life's coding problems, okay? You can use it, do I have this? Yeah, so you can use it to save time by having AI write code that you already understand, right? So if you're writing your 50th login page for the company, yeah, sure, get the AI to write the skeleton code for you, and that you could have done on your own, right? But please have a human verify that pull request. Don't just trust the AI for anything. If you don't trust me, just get AI to, like, what is the current example? It's like, you know, how many R's are in the word strawberry, and it just like gets it wrong. Draw me a picture of someone writing with their left hand. It can't do it. It'll draw someone writing with their right hand. Why? Because that's the training data it was trained on. These models are extremely flawed in some cases. So even at jobs where you are using AI and your boss is even telling you to use AI, you should not use AI to implement things you don't understand, because they could be incredibly insecure. They could leak my information, and I don't want that. So even just for my benefit, please don't use AI blindly to solve problems. This is my little motto. AI tools should type for you. They shouldn't think for you. So don't get them, and this is in industry, not in this class, okay? AI should not type for you in this class. Part of becoming a good programmer is getting that muscle memory of actually typing. Trust me. I used to do these programming competitions when I was in undergrad and grad school. And we would just sit there and just like, we'd solve a problem, and then the coach of that team would say, okay, now that you've solved the problem, just go type it into a blank text file 3 times. And you say, like, why? Why would I do something again that I've already done? Well, here's a good analogy. If you play any sport, let's say soccer, do you think that they got to be that good just having kicked the ball once? Oh, I scored a goal, I never have to kick that way again? No, they practice all the time. And the typing and getting used to inputting text is such a crazy valuable skill. You can literally be 3 or 4 times as fast as someone else just by typing, just by taking a solution and typing. The way I learned to program was, does anyone know the video game Quake? Yeah, it's like a really old first-person shooter. Like most first-person shooters today are inspired by this. I downloaded the source code for that. I didn't understand it. I just started retyping it. And from that, you start to get the idea, oh, this is what a function does. This is what a variable does, etc. So typing is a valuable skill as well. Also, for your benefit, getting a job requires passing an interview. You will not have AI in that interview. So another analogy of using AI in academia is like, okay, let's say you take a forklift to the gym, right? You take a machine that's going to lift the weights for you. And you come home and you're like, oh, I bench press 800 pounds today, right? And now you put on your resume, I can bench press 800 pounds. So you walk into an interview and the person there is like, cool, you can bench press 800 pounds, show me. And then you're like, can I use my forklift? And they're like, no, are you crazy? And so anyway, please, like, that's going to happen. It happens all the time. It's crazy. I have so many friends in industry, especially local industry now, who do these interviews. And some of the interviews are over in just like seconds because people are like just trying to use AI in the background on these Zoom interviews and stuff. It's real bad. Make sure you can answer the questions on your own. If you take shortcuts now, you'll take shortcuts forever. So please try not to take those shortcuts now. I speak to many people who comment on how interview skills have gone way down in the past 2 to 3 years because of AI usage. It's pretty I'm So some final thoughts. AI is a very useful tool to enhance productivity, right? And I'm falling into the trap here of calling LLMs AI, but it's just an easy way of describing this. There's lots more to AI. It can be helpful to learn topics, but you will need the knowledge on your own to pass an interview to get a job. Once you get the job, use as much AI as you can get away with, right? Have the AI do your whole job for you. I don't care. Use school to actually acquire knowledge and to get better at these skills. And then once you get the job, I don't care what you do. Here's some real consequences of all of this. So AI has, like I said, it has convinced middle management across the world that entry-level junior programmers are no longer necessary. It's a damn shame. There are a lot fewer jobs than there were just a few years ago. 2 years ago, I had companies calling and asking for recommendations of good students. Last year, even my best students are having trouble getting work. It has recovered slightly in the past, say, 6 months locally, but it is not going back to where it was. The tech market in St. John's has gone down significantly. Actually, this should say the past 3 or 4 years because it was at its peak around mid-COVID. Since 2021 or 2022, it started going down. So use this course to try and practice those skills that you'll need. Here's some like actual statistics about tech jobs overall. So around right before COVID, there was a dip, and then COVID, everyone was working from home. There was a huge job bubble because of all the working from home stuff. And unfortunately, this is probably when you guys enrolled in computer science because it was like, oh, I'll get a free job, right? And then the world rolls its dice, and for whatever reason, this is where we are right now. And so I'm not trying to depress you or get you to like drop out of CS. I'm trying to convince you to do as good as you can with the time you have remaining because it is deadly out there. It is kind of brutal right now in terms of getting jobs. Here's the same trend in many, many different places. Here it is again, sort of broken down. I'm giving you this. I'm not going to explain all about the graphs. I just kind of wanted you to have the graphs. But this one is almost more interesting. This is a 30-year or a 35-year view of what's going on, just to show you that traditionally, tech jobs have been a sort of boom and bust type of operation. There was a period of long stability in the 2010s, which was unusual, and then a huge bubble of work from home jobs around the pandemic. And now it is sort of normalized back to like this post-traumatic events that have been happening surrounding AI, etc. Hopefully this trend continues, and it's not this way when you graduate, but right now it's kind of bad. lots of layoffs and copycat layoffs of all the weird or the larger companies. Ghost jobs being posted everywhere. It's terrible. And not only are there fewer jobs, but up until 2024, I forgot to update this graph, because so the way it works with computer science, in my opinion, is that in the world, there's every year, there's a constant number of computer nerds. That number doesn't fluctuate. Like the people who actually are super interested in computer science. But the bubbles in graduation and enrollments and stuff are caused by bubbles in the job market, right? So the job market goes up. People look at that job market and say, I should get a job in that market. That is a perfectly reasonable thing to do. But because there was a bubble, the enrollments went up so high that now not only are there fewer jobs, but there's also 2 to 3 times as many people graduating. So it just kind of compounds the problem, which sucks. For graduate students, you are not immune to this either. A graduate degree in computer science used to be a golden ticket to just walk into a company and get a job. I'm just going to tell you, it's not that way anymore, right? There is such an inflation in graduate degrees. It's almost like a master's degree is the new undergrad degree, right? And I honestly don't even recommend people doing a PhD anymore. It's it does not necessarily help you get a job unless you want one of the top research science positions in the world, which you may or may not get anyway. Here's a local anecdote. I'm currently consulting with a couple different companies in town. One of them got 300 applications in 48 hours. In town, in St. John's, right? So you look around, it's okay, there aren't 300 people in this room, and those 300 people don't just come from this room. They come from all over the country, right? Because there's a lot of people looking for jobs. So you've got to be pretty high up amongst this class to have a chance. It sucks. It sucks right now, is what I'm telling you. And so try and use this opportunity to not bring a forklift to the gym, to actually work out your brain muscles. All right. This class, even though you can't release the source code, you can show off your work. I do recommend doing that. So the course is designed to be visual in its assignments so that you can show off a portfolio, etc. Okay, so now that the depressing stuff is over, just to bring you back into happiness, here are my cats. So I have 4 cats. If you ever want to show off cat pictures in my office, this is Freckles, this is Enzo, and Leela, and Stella. So they will be on the exam. No, I'm just joking. Okay, so all right, how much time do we have? Why isn't there a clock? Oh, I don't have presenter view, so I don't have a clock anymore. Just 1 second. 2:58. Okay. All right, so I got about 20 minutes left to go over some of the intro material. I know that took a lot longer than expected, but even though I went through that, and I say it every year, still 10% of you, I'll be telling, why did you use AI on these assignments? It sucks. All right, AI. What the hell is AI? I'll just tell you right now that if you ask 100 different computer scientists or AI researchers, you'll probably get 100 different answers. It's a very difficult question to answer, what AI is. It's almost a philosophical question. That question will not be on the exam for that reason. But these slides are sort of meant to give you a feeling for what AI is rather than a hard definition. Because I'm sure if you go out to Home Depot or Walmart and you try and buy a new toaster, it'll say there's AI in it, right? So AI has just become this term that's absolutely insane. But I'll give you my opinion on it. Intelligence. What is intelligence? Well, it's some capacity for maybe learning, reasoning, understanding, problem solving, that sort of thing, right? We could probably look at a rock and say that is not intelligent. We could look at a bird building a nest and say there is some level of intelligence there, right? Now, it is kind of crazy how we now have machines that are smarter than humans at some tasks. And what those things are rocks with lightning inside them. So somehow we took rocks, literally sand. If you don't know how computers are made, you should look it up. They take sand and put electricity in it, and now they can write poems. Isn't that it's so crazy? Anyway, None of you are responding, but it's fine. Like, hopefully someday you find that as crazy as I find it. So artificial intelligence then, in my opinion, is building some program or machine or process that appears intelligent to the user in some domain. And appears intelligent is really, really important here, right? Because it doesn't, like, what intelligent is, whether or not you argue is something intelligent, kind of doesn't matter. It's does it appear intelligent in some domain. And then if you hear about strong AI or general AI or the singularity or what's the term they're using now? Universal, whatever it is. Universal general intelligence or whatever. That would be like a system that's good at everything, right? I personally don't believe that's going to happen, but we'll see. So John McCarthy coined the term artificial intelligence. He developed Lisp. He won a Turing Award. And what he had to say was that AI is the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to the similar task of using computers to understand human intelligence, but AI does not have to confine itself to methods that are biologically observable. And so this is interesting, because if you had asked most people, what is AI, like in the 1990s, early 2000s, they would have probably said like the Terminator, right? Because the average person had only been exposed to AI through movies, right? It was this far-fetched, like science fiction topic, and AI just meant like trying to take over the world. That's basically what it was. And now if you ask someone what AI is, they'll probably tell you it's like slop videos on TikTok or ChatGPT, right? It has completely changed. But the important thing here, John McCarthy knew nothing about what AI has become, but he's saying it does not confine itself to methods that are biologically observable. That's the important part. So some people argue that because a neural net somehow resembles kind of what the brain is doing, then that is intelligence, whereas an algorithm that is discrete and not probabilistic is not that's all bullshit. It's like it doesn't have to be the same way that it works in nature in order for something to appear intelligent. So I don't like the term AI. I think machine intelligence is probably a better term, because artificial intelligence means that somehow there is a real intelligence. So what's the difference between a computer playing chess and a human playing chess? Is one real intelligence and one fake intelligence? So it just means, AI just means that it is some sort of intelligence that comes from a non-biological thing, the thing that is not actually alive, for whatever, definition of alive that you have, which would be an entirely other lecture. So AI is the science of making computers do things that require intelligence when done by humans. This is another sort of definition. So hopefully you get sort of an idea of what I'm going at here. AI, contrary to modern belief, has many, 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 many different sub-areas, to the point where it's almost like sickening now to try and say whether or not something is AI. You could probably twist the definition to make anything AI if you want to. Like an if statement could be AI, right? Because it's thinking. If hit points greater than 0, then whatever, right? So there's like, these are more traditional things. We have machine learning, lots of stuff in machine learning, natural language processing, expert systems, robotics, vision, planning, scheduling, and optimization. This is the area that the first half of this course will be focusing on. Planning, scheduling, optimization, those search algorithms. All right, hand up if you know who this is. Few people? Only a few people. Okay, so about 10 people. This is Alan Turing, the grandfather of computer science. He, probably more than any other single person, contributed to the outcome of World War II by breaking the German Enigma code. There's a movie called The Imitation Game. If you have not seen that movie, I highly recommend it, especially as a computer scientist. It's the story of Alan Turing at Bletchley Park trying to crack the German Enigma code. And it is absolutely fascinating. It's a little bit dramatized, but all movies have to be, right? They wouldn't want to just film a guy writing papers all day. So he wrote a paper called Computing Machinery and Intelligence in the 1940s. 40s, before there were computers. And he said that the definitions of machine and think are difficult. And, quote, "The original question, can machines think, I believe too meaningless to deserve discussion." And so I think it's maybe worth a discussion. But what he did was he posed that question as a game. And that is called the imitation game that movie is named after. So that game, it has many different formulations, but this is the most popular one. You have A and B. So on one side of some physical divider, you have a computer and a human, right? Maybe they're in another room, and there's some interface that you can chat with them. And then you have another person over here. So you have a human interrogator, and the point of this game is, can the interrogator determine which is the human and which is the computer via some sort of method, right? So does anyone know the more popular name of this game? The Turing test, right? Oh, by the way, just for future classes, if you have an answer to something, just put your hand up rather than yelling it out. So yeah, this is called the Turing test. And it's basically, the Turing test can be applied to either a general situation where you're talking about maybe conversation, but it could also be applied, there's, for example, in the video game AI literature that I'm involved in, there are Turing tests for video game AI agents, right? Because who's played a video game and the NPCs in the game are just obviously not acting human in any way, right? So one of the things that the gaming AI or the gaming industry wants to do is make their characters more believable as human characters, like they were in a movie instead of in a video game. So what they have, there may be a Turing test for NPCs in a video game. Can you tell if this person or this entity in a video game is being controlled by a human or by a computer? That would be a version of the Turing test. So that's an interesting test. It hasn't really been passed, but I guess you could say that modern LLMs do a pretty damn good job of conversational language, right? So we're getting there when it comes to conversation. So the Turing test basically says, can computers exhibit behavior which is indistinguishable from humans? And versions of this have been asked for literally centuries. Descartes, back in the 1600s, was thinking about automata. He was a famous French philosopher. He was the one who said, I think, therefore I am, if you've ever heard that quote before. Diderot in the 1700s made some philosophical arguments about parrots. Parrot, the bird who can speak, right? So if a parrot can speak, is it intelligent in its speech? Or is it just mimicking somehow exactly, right? That's actually a very fascinating question of whether or not that's intelligence or whether they just have some hard-coded thing that can reproduce sound like a tape recorder, right? 1936, Ayer talked about the consciousness of machines. I'm not going to list everybody who's ever had anything to say about AI and consciousness and the Turing test, but just to let you know that this is not a new problem. People have been thinking about this for a very long time. John Searle in 1980 posed this thought experiment called the Chinese room thought experiment. It is he just called it the Chinese room because Mandarin, when you write it down, it is very difficult for English people to read, right? So in this thought experiment, what you have is, this is sort of a black box. The people on the outside don't know what is going on inside this box. So the thought experiment was, which was mostly philosophical, if someone out here speaks one language, doesn't have to be Chinese, of course, it could be any language, and someone out here speaks another language, right? This person is feeding in symbols or words or sentences into this box, and outside the box is the other language, perfectly translated. But what he said is that inside the box here is a person who doesn't speak either of those languages. They're not actually understanding anything. What they have is a giant book. And this book has all the symbol translations from one language into the other language. And they're saying, so this person, without any understanding of what's being said or what's being given, can perfectly translate from one language into another. And he said, is that intelligence? Right? To the outside, it looks incredibly intelligent. Something intelligent is happening in that box. But really, the only intelligent thing was the creation of that book, right? And his argument is this is literally what computers do. They are given some set of instructions, they look them up in a big book, and they give the output. So therefore, since there is no whatever we would consider understanding of a problem by the machines, then machines cannot, by definition, show intelligence. So Searle was saying, by looking up rules and performing translation, the person appears to know the language and appears intelligent. But the people on the more human side of things are saying that because it's just a translation, an automatic carrying out of rules, then there's no understanding of the semantics of what's happening, and therefore the Turing test is inadequate. Because if the thing doesn't understand anything, then what does intelligence even mean? Right? Now, this is obviously not something that I can put on the exam. I'm not going to say who proposed this experiment or whatever. This is more so to just kind of get you ready and thinking about what intelligence might mean. Because it's a very difficult question to answer. And if any single person ever tells you that they know exactly what intelligence means and what AI means, and this is intelligent and this is not, be very wary of that person. Because a lot of very smart people, much smarter than me and much smarter than them, have no idea what the answer to that question is. And this is the type of philosophical argument that's really like, it's not really provable, it's more so like opinion. It's just a sort of a thought piece. So what I like to say, what I like to do is instead of make these philosophical arguments, is to maybe say, like, what can these systems actually do, right? Not just make all these philosophical arguments. Now, when I made these slides for the first time about 10 years ago, a lot of people had not been introduced to AI and what it could do. Like, for example, Google Maps. This is probably the AI that most people were using 10 years ago. There are search algorithms that we will learn in this class that power Google Maps, right? How do I get from point A to B as fast as possible? Autonomous control. There are self-driving cars out there right now. They're not as perfect as certain CEOs would have you believe, but they do exist. Image recognition, pattern recognition. Since the 1980s, the vast majority of all letters in the post office, at least in North America, have been scanned and identified by computers. Facial recognition, a technology I wish was banned in all forms because it's being used to do some bad stuff. That's something that AI can be used to do. Healthcare, it is making its way into healthcare more and more often. Computers and AI systems are already better than humans at things like detecting cancerous growths in MRI scans, at when given proper information, at diagnosing things. Please don't rely on ChatGPT for self-diagnosis. It oftentimes just tells you what you want to hear. But it is great that doctors can now use systems like this to help them with their jobs. Robotics. Over here is an example of something called swarm robotics, where you take a bunch of really tiny dumb things, and then together they make one bigger smart thing. Over here is a now old example of a Boston Dynamics robot being tortured for some reason. Like, this is what the robots are going to remember, right, when they take over. Just some examples of what things can do. Who has heard AI music? Okay, so most people, wasn't like one of the top songs on Spotify, like AI generated last year? It's crazy. Obviously this is a joke, but this is an actual robot band that plays music. Art, I mean, this was the first, write down, does anyone remember the name of this thing? This was the first AI image generation released by Google. It's called Deep Dream, and it created this like nightmare fuel. And it was really the beginning of this process called stable diffusion that ended up generating all sorts of modern AI generators. This was called style transfer, where you could take a video and an image and transfer it to the style of that image. And now, of course, you could take a picture of me and have me doing jumping jacks out in the snow in 5 minutes. It's just insane. I don't even want to talk about it. So I had an example of this because when I wrote the slide, this was still like state of the art, even like 3 years ago, right? So, but you all know this now. I wrote this. Of course, it can solve assignments. Okay. I'm personally interested in the game industry. That's what my research is about. I play a lot of video games. It is very helpful in that industry for doing things like brainstorming, prototyping, proof of concept work, etc. Procedural content generation is a big part of the game industry, and this is algorithmic. This has nothing to do with LLMs. Like AI can be used in that way. Language processing and translation. Who has used their phone to translate like a sign in real time? I've done that while traveling, man. And that's like, again, this is like 10 years old. You're all familiar with that, but it's great. And obviously take over the world, right? What I'm most interested in is game playing. One of the interesting things is that when you come up with a new AI solution for something, it's very difficult to just measure intelligence. And so what people have done traditionally over the years is play games with their new algorithms. Because in a game like Go or chess or StarCraft or whatever, there's a winner and a loser. And so if something wins more than it loses, it's probably more intelligent than the other thing. So this is why AI has been used for so long. But the last thing I'll mention is how do we actually make new AI? Like, how do these algorithms go from not existing to existing? Well, that would be like AI research and development. So this is what would happen in grad school, in bigger companies, etc. So you'd first identify some problem or area that you want to work in. Then you'd review the literature of existing techniques. Despite what NVIDIA and Google and Meta and all these companies, OpenAI, would have you believe, they did not invent the wheel, okay? This has been building for many, many decades and finally got to the point where they could capitalize on it financially. And the world only starts to care about something when people start to make money from it. So you review what's been done in the past, you develop some new technique by like enhancing what has been done previously, then you test the new techniques against the old techniques under the state of the art at the time, under some specific controlled circumstances, and then you can apply the new techniques to the problem. And so how do we test AI? Well, one of the things that I do is play games. And games measure intelligence, and in my opinion, everything is a game. I have not come across an example of something that is not. Life, survival, jobs, relationships, everything is a game that has some evaluation function that you are trying to minimize or maximize. And so, yeah, so what is a game? It's an agent in an environment. The agent takes actions. The actions affect that environment. The only thing that differs is the environment itself that you act in and the goal of the agent. It might be defeat the opponent, move to the right, solve the puzzle, get the most points, have the most children, make the most money, do as well in the stock market, guess the best grades. It's all a game. Some games have more serious outcomes than others, but I'll leave it there for now.